Let's talk about parameters and statistics. An index of a characteristic of scores in a population is called a parameter. An index of a characteristic of scores in a sample is called a statistic. For example, the mean height of American women is a parameter. Why? Because the mean is an index of scores, and because when we're talking about all American women, we're talking about a population. An index for a population is a parameter. Typically, parameters are not available to us. If they were, this class would probably be called parameters instead of statistics. What's available to us is the sample, and an index of characteristic of scores in a sample is called a statistic. So the mean height of a random sample of American women would be a statistic. There are several properties about parameters that you should know. 1. They define the mathematical model that is used as the probability distribution. Well, what do we mean by that? Take a look at this example that you've seen before. Here we have a normal distribution of female heights. Where did this come from? Well, if you look at the commands that we use to create this distribution, it relies on the mean and the standard deviation. That is, once we set the parameter mean and standard deviation, we can then use the function in R in order to create a normal distribution. And not just any normal distribution, a normal distribution with that mean and that standard deviation. So that mathematical model is defined by whatever we set the mean at and the standard deviation. So that's what we mean when we say that a parameter defines the mathematical model that is used as the probability distribution. The normal curve is defined by two parameters, the population mean and the population standard deviation. Another thing to know about parameters is that they are constant for a specified population. That is, once we define a population, there's a defined mean for that population. There's a defined standard deviation. It's a single number. The problem is that number is usually unattainable because we cannot measure the entire population. That's why we turn to statistics to estimate the population parameter. It's just an estimate. It doesn't mean that we have the correct population parameter, but based upon our sample data, it's our best guess of the population parameter. And we use statistics because we have samples available to us and we can easily calculate the statistic from the sample data. Unlike a population in which the parameters are constant, statistics vary from sample to sample. Remember when we took repeated random samplings and we looked at some of them? Every time we took a new sample, we got a different bar graph or a different histogram. And associated with that, the statistics are different too. So statistics vary from sample to sample. A population stays constant, so the parameter does as well.